Good morning. I am going to introduce you to a small script for blended Python. I'm learning this language now. I have some notions of Python, but I am learning how to work with classes and to make more complex things inside Blender. Okay. I would like to describe a little what this script does. This script is quite simple. The only thing that it does is to generate some Keva plank for future physics simulations that I want to do inside Blender, but at the moment is the scope of the script is only generating the geometry. And the moment this script, at the moment, the only thing that it does is to generate a cycle of Keva planks prepared for doing physics simulations. Okay. Well, I am going to describe the script. The script is quite easy. The first point is to import the used libraries inside the program. These libraries, as you can see, are BPY. This is a Blender Python library. NumPy is a mathematical library for Python. Math library from Python. And BMES, that is an utility MES that Blender uses an utility library, that Blender uses to generate the internal meshes in an easy way. Okay. Well, as you can see, I have several functions here defined. These three functions are rotations along the Cartesian axis. One for the x-axis, y-axis, z-axis. Okay, this function, is generates the composition of the three rotation matrices are generated before. Okay, and this function is the most important function that I am using here. Is a circle function that generates given two arguments that are the radii of the cycle and the number of points in the cycle. It generates the physical points along the curve and the rotation angles for each point. Okay, as you can see, the only thing it does is making a loop running along all number of points. It generates the angles, stores the angles in the list that is going to be returned, and it generates the physical points rotated along the 0 position. Okay, and it stores it in a point vector. Well, in fact, list. Okay, this is a list of vectors of 3 points or 3 coordinates. Okay. Well, I was trying to testing some inheritance classes. It's not necessary for this code, but well, it's only for testing. I generate a parent class. It's called the MCL project element, but it has nothing inside. It's only for testing how to call the testing functions and things like that, but it's not relevant for this code. And this is the main class. This class is in charge of generation of all the Keva planks. Okay, this class, as you can see, inherits from the MCL project element, and you can see that the members of this class are 4. Is the sizes in Cartesian axis, Euler angles, these rotations along the axes, and the position. This is the initial point in the Keva point. Okay, and we store internally the rotation matrix that is going to be generated with all the Euler angles and the corresponding matrices. Okay, Well, these are some methods not useful for this. It's only for learning and testing purposes. But well, this method is important. This is the calculation of the rotation matrix for each Euler angle. Okay, you have the three Euler angles, and we are able to generate the rotation matrix using the composition between, of all the single Cartesian rotation matrices. This function method or function is important also, is this is the generation of the basic points of a Keva plant. Okay, these basic points are generated in a non-rotated Cartesian axis. Okay, as you can see, the initial point is always generated on the coordinate of c 0 c 0. Okay, and we generate 8 points, 4 for the base and 4 for the upper base. Okay, this is a function that calculates the indexes of points used in each Keva Planck phase. As you can see, there are 6 phases, and each one has 4 integer numbers that references the position of the points generated before. Okay, this is one important method. This method calculates the rotation matrix with the current Euler angles. It calculates the points and it rotates the points using the rotation matrix for each non-rotated point values. Finally, these points are returned when you call this method. Okay, this is the most important method. This method generates a BMS. This is, as I told before, BMS is the internal Blender way of generating meshes in an easy way. Okay, so for generating this mesh, I give this method. I give the phase and the point array, and it will generate a BMS with all the points and all the phases. As you can see, this method is generic. You can use this method for whatever combination of phases array and points array. As you can see, we evaluate how many points you have the method has received, and for each point of receive, this loop generates a vertex inside the BMS class. It's the same for the phases. It calculates how many phases have received, and it generates the phases with these values. It should be consistent. It's important that the numbers included in the phases array should have his corresponding point in the point vector. Okay. Well, this is a test function. It's not using now, but this is a real one. Okay, I will explain to you a little about this function. This function, the first thing that it does is generate a collection. This is important because if I generate objects here, I have to delete each one of them, and it's a boring task. So we always develop for making less work. So I generate a collection, and I will link all the objects to the collection. So when all the objects are generated, if I wanted to delete them, the only thing I have to do is to delete the collection. Okay. As you can see, I can give you the radii and the number of points generated, and well, it generates an only one NGMCL Planck class. I am going to use this class for generating each one of the BMS. So I only need one. Okay, with the number of points that I have generated, I run. First of all, I have to generate the points with the cycle method, I generate the physical points and the angles I have to rotate the Keva planks. Okay, I run along all the points I have generated. I modify the GMCL plank class position, and I generate. I modify also the third component of the Euler angle. Okay, with the angle I have received from this function. I generate the BMS. I calculate for the GMCL plank class the rotation. I calculate the rotated points and the faces, and I generate a new BMS for each iteration in the loop. With this BMS, I extract the required mesh data, and I generate a new object in the outliner with this data. As long as I told you before, I don't want to have all the elements linked directly here. I link them to the collection that I generate at the beginning of the script. Okay? I will show you how you run this. If I press Alt P, I run the script, and as you can see, all the elements have been generated here. In this case, 40 Keva planks. As you can see, I have my collection and all the new elements generated here. For example, I can modify the radii. I am going to use 30, and I use the half part of number of points, 20 points. If I press Alt P again, I generate a new collection with the radii that I have defined and the number of points. It's interesting to see that the collection I have generated now is this one. You can see that the name is not the same name I have put before. This is because Blender detects that there is a collection here with this name and generates a version of this name. Okay? If I link the collections with the name, this object will be generated with the first collection, not with the second one. But as I told you, I generate the collection, I recover the object, and I use the object to link the collection, to link the object to the collection. This is the reason I can have all these elements in a collection that doesn't have the name I give in the script. Okay. One last thing, as I told you, my intention of using collection is because it's easier to delete the collection, and I can delete with the delete directly, and it deletes all the objects in the collection. CM is the same, and I have the interface clean to begin the script again. Well, this is all. It's only a test of doing a small tutorial about Blender scripting, because I am learning now how to make scripts in Python in Blender, and I hope you enjoy it and will be useful. Okay, thank you very much.